The world's data centers are about to hit a wall, not a physical one, but something far more dangerous: the complete breakdown of how we store information. And while everyone's been focused on AI and quantum computing, two unlikely players just revealed they've been secretly working on the same radical solution that sounds like science fiction.
A UK startup claims they can store your data for 13.8 billion years. That's longer than the universe has existed. Microsoft says they've already stored an entire Hollywood movie in a piece of glass that survived being boiled, frozen, and hit with electromagnetic pulses. When a tiny startup and a trillion-dollar tech giant independently arrive at the same breakthrough, something massive is happening behind the scenes. Here's what nobody's talking about. Right now, somewhere in the world, a data center is frantically copying information from failing hard drives to new ones. This happens every single day, millions of times, burning through electricity and hardware just to keep data alive. The dirty secret of the digital age is that our storage systems are fundamentally broken, and we've been hiding it with an endless game of musical chairs. The numbers are staggering. Studies reveal that 60 to 80% of all data on Earth is what they call cold data. Information that rarely gets accessed, but can never be deleted. Think medical records, financial transactions, government documents, research data. This mountain of information doubles every 2 years, and we're running out of ways to store it. Traditional hard drives fail within 5 years in data center conditions. Magnetic tape lasts longer, maybe 30 years if you're lucky, but it still degrades. When that happens, everything must be copied to fresh media, then copied again, and again. This migration cycle never ends, consuming massive amounts of energy and money just to preserve data that never changes. Enter glass storage, a technology so counterintuitive it sounds impossible. Instead of storing data on surfaces like every storage device you've ever used, these systems write information directly inside glass using lasers. Not on it, but actually inside the molecular structure of the glass itself. The UK startup making waves is called Sphoenix, founded in 2024 as a spinout from the University of Southampton. Their researchers have been quietly developing this technology for over a decade. What they've created defies conventional thinking about data storage. Their system uses something called five-dimensional optical data storage. Here's where it gets wild. Data isn't just written in 3 dimensions like you'd expect. Each tiny data point, called a voxel, has 5 independent properties: its position in 3D space, plus its orientation and optical intensity. This allows an astronomical amount of information to be packed into a piece of glass the size of a DVD. The writing process uses femtosecond lasers, pulses of light so brief they last just quadrillionths of a second. These ultra-short bursts create permanent nanostructures inside fused silica glass without damaging the surrounding material. Once written, the data requires zero power to maintain. No cooling, no maintenance. It just exists, frozen in glass. Reading the data back involves shining polarized light through the glass and detecting how those nanostructures bend and change the light. Advanced software then reconstructs the original information. Current prototypes achieve write speeds of 4 megabytes per second and read speeds of 30 megabytes per second. By modern standards, that's glacially slow. But here's the thing. Archival storage doesn't need speed, it needs permanence. The durability claims sound like fantasy. Sphoenix says their glass discs can survive 13.8 billion years at room temperature. That number isn't marketing hype. It comes from the fundamental physics of fused silica glass. Unlike magnetic or electronic storage, glass has no known decay mechanism. It doesn't demagnetize, it doesn't leak charge, it doesn't chemically break down under normal conditions. This technology first grabbed headlines in 2013 when researchers successfully demonstrated 5D recording in glass. The real publicity coup came in 2018 when a data crystal hitched a ride on SpaceX's Falcon Heavy launch, the same mission carrying Elon Musk's Tesla Roadster. That wasn't about making a product. It was about proving the technology could survive the most extreme conditions imaginable. Now Sphoenix claims they're ready for prime time. They've raised $4.5 million and say they'll have systems ready for data center pilots within 2 years. Early units are projected to cost around $30,000 for writers and $6,000 for readers. Their roadmap targets 500 megabytes per second read and write speeds within 4 years. But here's where the story takes an unexpected turn. While this UK startup was developing their technology, Microsoft was secretly working on virtually the same concept through something called Project Silica. And they've been at it much longer. Microsoft Research launched Project Silica around 2016, driven by a growing realization that magnetic storage couldn't sustainably scale with cloud data growth. From day one, this wasn't a research curiosity. It was designed as a cloud-native archival system for hyperscale data centers. The Microsoft approach uses ultra-fast, femtosecond lasers to create permanent nanostructures deep inside quartz glass. Just like the UK startup system, data is stored volumetrically throughout the glass rather than on a surface. But Microsoft took a different path in proving their technology. In their most famous demonstration, Microsoft partnered with Warner Bros. To store an entire Hollywood movie in glass. They chose the 1978 Superman film specifically because it represented a real production-grade dataset, not some synthetic test file. The entire movie was encoded into a quartz glass plate, stored, retrieved, and played back with zero data loss. Microsoft's testing went extreme. They boiled their glass storage in water. They scratched it, baked it at high temperatures, hit it with electromagnetic pulses. The data survived everything. Traditional storage media would have failed completely under any one of these conditions. What sets Microsoft's approach apart is their system-level thinking. Project Silica envisions robotic libraries where glass plates sit on passive shelves requiring no power or cooling. When data is needed, robots retrieve specific plates and bring them to readers. The rest of the time, the archive consumes virtually no energy. This design has profound security implications. Glass storage is inherently air-gapped when not being read. No electronics means no vulnerability to ransomware, remote attacks, or persistent malware. For governments and regulated industries, this represents the ultimate in data security. Microsoft frames their durability claims more conservatively than the UK startup, typically citing thousands to tens of thousands of years rather than billions. This reflects enterprise risk assessment rather than material limitations. The underlying physics remains the same. Properly stored glass should outlast any timescale relevant to human civilization. The investment levels reveal how seriously Microsoft takes this technology. While exact figures aren't public, industry estimates suggest Microsoft has poured well over $300 million into Project Silica, potentially approaching $500 million over the project's lifetime. Both approaches face the same fundamental constraint: physics. Writing data into glass means physically forming structures with lasers, a process that can't be rushed without losing precision. Reading requires careful optical scanning. No amount of engineering can eliminate these physical requirements. This is why glass storage will never compete with SSDs for speed. It's designed for a completely different purpose, trading performance for permanence, energy efficiency, and extreme durability. It's infrastructure for humanity's permanent record, not everyday computing. The race between these two approaches is fascinating. Microsoft has scale, capital, and cloud infrastructure. If glass storage becomes mainstream, they're positioned to integrate it seamlessly into their Azure platform. Customers would interact with familiar cloud APIs, while their cold data quietly migrates from tape to glass. Sphoenix takes a different strategy. Rather than building cloud services, they're positioning themselves as technology suppliers to existing data centers. They want to license their glass media and optical systems to others, becoming the arms dealer rather than fighting the war. Other players are emerging too. Companies like Cerabyte are developing laser-written storage using ceramic materials instead of glass. The proliferation of similar approaches suggests the industry recognizes that current storage methods are unsustainable. The implications stretch far beyond technology. For the first time in human history, we might have a realistic way to preserve information longer than civilizations typically last. Digital archaeology could become real, future humans discovering perfectly preserved records from our era thousands of years from now. The environmental impact could be transformative. Eliminating the constant migration cycle would slash data center energy consumption. No more manufacturing millions of hard drives just to replace failing ones. No more tape degradation, just write once and forget. The next 2 years will be critical. Will the aggressive UK startup beat Microsoft to market, or will the tech giant's methodical approach and deep pockets win out? Either way, the convergence on glass storage from multiple directions suggests we're witnessing the birth of a new era in information preservation.
The question isn't whether glass storage will happen, it's who will make it happen first, and what it means for the future of human knowledge. When both startups and tech giants bet on the same radical technology, the smart money says the world is about to change. That's it for today, folks. See you in the next video.